Thanks for the introduction. And thanks for everybody for coming. I'll be presenting our work on Pribot, which is a chatbot for privacy policies. This is joint work with Kassem, Rémi, Florian, Kang, and Karl from EPFL and the University of Michigan. So the problem we tackle here is the following, which is best represented with this video. Company hired this guy to Kindle's privacy policy.
2016. Your content, or otherwise tamper with your content or create.
Resale or a gift for your book, gift certificate.
Kindle certified service provider. Kindle cloud reader design. Kindle bundled with
Copyright 199214.
Amazon cloud drives, photos, and copyright like
Name of copyright owner. 3 iPhone sets created by Mark Jenkins and from other dealings in the pop culture.
After 5 minutes of activity, with the microphone off, your device will enter sleep mode to conserve power. The end.
So this guy was hired to do this, and there's the full 9-hour episodes on YouTube that you can check if you are interested. Okay, so what do we do? So our idea is that because privacy policies are long and complex, let's turn them into a conversation. So why does this make sense? In this era, you can think about UI-limited devices such as voice-activated devices, which do not have screens. So how do we ask users for consent when signing up to applications on these platforms? Do you, for example, read the whole policy when you are on Amazon Alexa? Do you ask it what is the privacy policy and you spend time listening to it? Or do you actually rely on secondary devices? So currently the case is that you check the policy on your phone and then you use the app on the other device. But with time, actually, Amazon has, for example, moved to another model where you can actually use the service without having to install the app. So you just say, I want to do this, and Amazon figures out the skill for you and then allows you to use the app. So even they're moving more and more towards relying on the device alone without having to install an app externally. And Amazon and others in this case have been, in fact, taking the usability to the extreme. That is, they're prioritizing usability and ignoring privacy, but in fact, we think that there might be a middle ground between the two. And privacy policies are also important because customers ask about privacy and security practices of companies. And if you check Twitter, you will find a lot of people asking companies for what do you do. Often the answer is, go check our privacy policy. And if we are moving towards automated customer support, you will see that this does not scale well. You cannot just tell the users, go read our privacy policy. So we need more and more automated question answering, and we think that general question answering made for general domains does not work well with privacy policies, and therefore we need a specific approach for policies themselves. So the approach we have is automated question answering. So given a question, given a privacy policy, we first take the policy and split it into answers. We get the answers from the policy by doing a custom HTML scraping and keeping answers coherent, talking about the same topic. So they are generally excerpts from the policy itself. Then we rank these answers according to their relevance to the user's question. And finally, we present them in an interface. This can be a chatbot, this can be a Twitter bot, this can be a voice skill, etc. So I told you about the why. Now, before going to the how, let me tell you the what. So this is a Pribot in action. In fact, I had a video, but I know nobody likes videos, so I'll go to the live demo. Hopefully it will work. So this is, all right. So this is Pribot. This is the interface. So once you go, it's not yet public, so it's internally for us still in beta version. So the idea is that you can ask about the company you want. So let me ask about, for example, the company we work with at EPFL, it's Oyoti. It's an AI assistant for children on social media. So this session is about Oyoti. We had Oyoti analyzed before in Pribot. I will not go through how do we do that in the interface, but this is just now analyzed. So the question is, like, do you share my data with third parties? Alright, so you will get that the first answer is about, we remove, if you can read it, we may remove parts of the data, we can also combine and share that aggregated information. So it talks about sharing the aggregated information. And that we'll show the top 3 answers to your question. So this is another question. We may share part of this information with technology providers such as etc. etc. This is a third answer. Just pretty longer one. So it talks about sharing data with Google Analytics and others. Sometimes we don't want this whole thing to be read. We want something simpler. And we also, in Pribot, we also have a mode. We translate this on a high level to something simpler. So instead of reading that, you read a high-level summary of what it is. This is a generic summary, not talking about the details. And this is like we use services from third parties, which allow them to collect data from you when you use our service, for example, etc. So let me ask another question to Oyoti. For example, how long does my data remain? And notice that I'm not using exactly the words which do have to occur in the privacy policy, which can be legal words. I'm using my own language, and you will see now, for example, so how long does my data remain? So the excerpt which was most relevant is the following. Let me remove the translation mode. So if user deletes their account, all information, etc., and all records will be deleted from our server within 6 months. So this was the closest one to that question. There are other answers, so it's not necessarily, the answers not necessarily be about exactly the question, because the top answer usually answers best, but they might be relevant. Again, this I showed you before that this can be translated, and we can also translate this into a higher level. So you notice you benefit from a right to access, modify, rectify, or have rectified, oppose, and have deleted. Okay, so the language is pretty not easy. So I think there's on average 4 grades or 5 grades difference between grades in terms of the school grade that is necessary to read this sentence between this one and between a simplified one. We give you the option to modify or delete specific information. So this is Pribot in action. Now, how do we do that? So to go back, I will focus mostly on the privacy QA ranking algorithm. That is, how do we get the most relevant answer to the question? And so, given a question, for example, to whom do you expose my content? We answer, for example, if we want to answer this question, the idea is that the user is using a wording which might not necessarily be in the policy. The policy might have the legal explanation. So how do we match users' wordings from outside to the policy's language? And the second one is that if I ask, do you expose my content, and I use traditional approaches, I will not be able to account for, is this content about third-party sharing, or is this about data collection by the company itself, which is kept for the company itself? So the first thing is that one can think about, which is now trendy, is that, okay, let's use word embeddings, which is a semantic way of matching words which are not the same. And actually we use general embeddings, word embeddings in our approach. We use a general one which we hope that captured the similarity between legal language and non-legal language. Now, we also use neural networks. So neural networks typically feed on labeled data, but we don't have QA data. We don't have a database of 100,000 questions which have been answered by people. And in order to build a question answering system, what we do is that we go for classification data. So what classification data we use, there is a good data set of privacy policies which have been labeled sentence by legal experts. This has been a project at CMU, and we benefit from this data set, which looks like this. You have the paragraph, and each sentence is labeled according to high-level labels, which is user access, edit, and deletion, and low-level labels, edit information, for example. This looks more like this. There's a structure here. There is like high-level, first-party, third-party, data security, and low-level, like information type. So I'm not talking about all the approaches, but our best performing approach was a hierarchical model, which looks like this. At the first level, we have a classifier which classifies, is this first party, third party, etc. And low level, we classify, is it financial information, is it location information? Then we combine these together in order to arrive at a representation vector. This vector says, okay, this is the representation of a segment. And in order to bring questions close to answers, we just measure the difference between their vectors. This is our approach, which we hope captures this similarity. Each of these classifiers on each node is a neural network classifier. I will not go into the details, but this approach actually performs well in matching the user wording and in capturing the generality specificity part. So in order to evaluate this, we went to Twitter, we collected questions of people on social media asking about privacy policies. We had an approach in order to get questions from companies' answers, actually. So answers like, go check our privacy policy, we go and see the question that was about this. In our evaluation, we used 120 questions. We evaluated them in two ways. We evaluated the predictive accuracy, that is, how much do these answers match with expert answers. And we asked two experts to do the answers for the 120 questions, and we compared that with the model-generated answers. We found that among the top K answers, what was the percentage of cases where there was one expert answer among the top K? And we found out, I'm not going to the graph, but we found out that 64% of the questions had accurate answer among the top 3. Think about the policies which have 50 on average answers that have to be read. So we're reducing something in 10, 15 minutes to like 20 seconds. So we were able to compare this model that we had against other models, traditional models, and to show its efficacy. We also did user perceived utility, that is how much users think that this is an answer to the question if we give the answers to the users. And we found out, in summary, that 91% of the cases, there was at least one answer in the top 3 answers generated by our best models. And that was the finding. So that was the idea of Pribot. So in general, I will not also go into that, but the chatbots, in my opinion, are not only about deep learning. There's a lot about how do you present these to the user, how do you perfect the UI and the UX, and how do you balance the accuracy with too much information to the user. And that is the idea is that not everything has to be deep learning based. If you see, our chatbot has a deep learning core, but it has a framework based, it's called RiseScript, in order to manage the conversation itself. And then the answers are fetched with deep learning. That's it. I leave you with the questions and feedback if you have. Thank you.
Thank you very much. Question over there?
Yeah. How scalable is your approach to applying this to a completely different set of data?
It can take any policy which has never seen before, and the idea is that we try to answer. So these answers that evaluation was done on policies we haven't seen. Actually, just took so we collected data from Twitter where the company says check our policy, and this is the link. We capture the link, we get the answers from the link, and we give them to the evaluation. So these are policies, this evaluation is done on policies we haven't seen before.
But what about words you haven't seen before? A lot of policies may mention dictionary words.
So that's the power of the word embedding, which is general. So if you use a word embedding, which is pre-trained word embedding, and you freeze that embedding, I didn't go into that, but if you freeze the embeddings at that training time, you still be able to capture words that you haven't seen before. Yes.
How many different questions did you find when you were looking at this data? I mean, talking about privacy policies, how many types of different questions does someone ask about the privacy policy?
Yeah, so it's an interesting question because we find if you're talking about types of questions, I think that categorization of questions is captured well by our taxonomy that we had. So you can reformulate that question in infinite number of ways, but the categories we're talking about, we had like 9 high-level categories, and I think in the lowest level we had in total 81 classes. That is something like financial information on the lower level and like first-party collection on the higher level. So this is the size of the taxonomy, which gives an idea of how many categories, but the questions could be infinite formulations.
Right, but so then if you would just have a list of possible questions like an FAQ, would that?
Yes, if you want to specify this is the questions that you can ask, then yes, you can do that. But if you want to let the user ask any question, you can imagine when you're given Alexa, you cannot see a FAQ. So you just come up with your own question on the fly. You can ask about what are the frequently asked questions and get answers, but that's another way.
Yes, please.
Was that summary that you showed of these snippets, was that specific to these policy issues, or was that just a common text summary?
Yes, it is generic text which is generated. There we use the classes that we have classified the data into. So if we know that this is about financial information and this is about sharing with third parties, we have a rule-based model in order to generate sentences which make sense and coherent from these classes. And this, we think, is a way to present the things in an easier language to the user. This is not like, the generation here is not like a deep learning generator, but the classes are found with our classifiers.
But so if then there's a kind of just a little change in these two sentences, then you probably get a wrong summary, right?
Not necessarily. So an interesting validation of why this is not necessarily the case is that a lot of the cases when we had Twitter questions, Twitter is not a formal context which you ask in formal context. We had a lot of cases. So we in our evaluation we had spelling mistakes even. We had like informal language, somebody saying sarcastic stuff. So this is like the worst case that can happen is that you have people like asking like they ask on Twitter to other people. And even with that case, if there are enough clues in the sentence about what you are asking about, then this is enough to capture. So in general, if you vary, you change the word like how long is my data kept, or how long is my data retained or remains. The top answer, 2 or 3 answers will be mostly the same.
Last question.
Yeah, do you have some kind of confidence score when giving an answer? Because I think there will be questions which you cannot answer by just giving back one snippet. Maybe you have to infer it from different snippets, so which might be very hard to answer.
Yeah, so there are 2 aspects to that answer. So we don't display yet a confidence score to the user. But this would be an interesting next step we have actually, because we want to tell the user sometimes the answer is not in the policy, so we want to show the confidence. This is not yet in Pribot. The other part is that what do you do with answers found in different places? So actually, in some cases there is even contradiction. Sometimes the company says we share, and then later they say except in these cases. So we also have a classifier that classifies whether they say we share or we do not share for this specific case. And we aim later to integrate that into the interface to say there is contradiction about sharing and these are the segments.
Okay, thank you very much for the talk.